You're a right guy. You know that.
Mhm. You're right. Yeah.
So we might have to have you summarize your question, but, yeah, so I definitely think that there's, we're at, just to address the initial part of the question was, this is the start of sort of the education piece, and we're trying to bring everyone together here. And us as an agency, we're, we definitely see the potential here, and we're trying to connect those pieces with our other agencies and other partners here. So I think there's more that needs to be fleshed out, no pun intended.
I've been waiting to say that.
You're flowing so well.
No, but seriously, you heard Sean's comments. I mean, if anyone would like to comment on sort of, from an engineering perspective, sort of pulling those pieces together, and I think the technology providers had talked a little bit about this in their remarks, but I just want to open that up to the technology providers or others to address maybe some of the initial comments that
About the questions of resiliency?
that was the second part of it. I think it was just, well, go ahead, Sean.
Why don't we start there? Go resiliency and then work our way back up.
So there's a number of conversations around resiliency. So just from a community resiliency standpoint, let's just imagine a thermal network supporting an entire area. There's a grid outage with a small generator or battery. You can move pumps and to move that fluid around, and literally with the little electricity that our systems require, we're now able to heat, cool, make domestic hot water, even in the time of a natural disaster, if you will. So there's that resiliency part of things. Then there's the job creation. I was talking to this gentleman earlier about my conversations have just taken off on a rocket ever since the unions got behind us. And like, oh, because they see thermal pipes on the rise and they want their members on those pipes. So the job creation, you're getting, better air quality. So there's community resiliency in that regard, right? And then beyond that, from a pipe standpoint, and this is actually an ORIG installation at the AGU in DC. I can never remember.
Hoover?
I'm so sorry.
Same server, but
And one of our systems out in Seattle, where they had an ancient pipe, and like, well, how are we going to connect to this pipe? Well, it turns out that in order to connect to the pipe, they had to remediate that section of pipe by putting in carbon fiber lining. So all of a sudden, the sewer authority now has, in addition to a new off-taker, a new revenue stream, because they can charge money for that KW in and out of the pipe. Now they have a new 100-feet section of pipe that they can reliably say that's good to go. So there's a infrastructure resiliency play as well. So there's many ways you can slice that term. I'm sorry if I went off a little bit there, but that's
So before you go on, so you talked about power usage. Does that mean that you have a small generator that's associated with your system?
well, that would be the smart thing to have a generator side by side. Yes.
Right. Okay. And then you talked about that small section of the pipe. So if other portions of the pipe need to be rehabilitated, how does that impact your installation?
You want to get into that?
yeah, so I mean, there's a couple of ways. So it really depends on the scale, and obviously depends on how much resiliency you want to build. So it's becoming more important, especially in a healthcare setting. So for example, I'll talk about the big hospital one. There are two sewer lines actually, right? So phase one, we're accessing one. Phase two, if the resiliency is desired, you put a second wet well, right? Also, to Aaron's point, we're moving around energy. So in the Toronto Western, there's the hospital and there's a research tower right next to it, each with a standalone plant. Now we're able to take the research tower's natural gas, whatever boiler plant, and we can take that energy if needed and move it to the hospital. In terms of heat rejection, very inexpensive to add cooling towers. And for heat generation, an electric boiler in the worst case, right, as a backup to backup. On top of that, thermal storage. So there are different ways. It's either by having multiple sources. This is why we want decentralized grids, decentralized resources. The more people you have adding or removing heat, the better you are to move it around. It's really only limited by our imagination and, cost. But, when you're looking at sometimes a power purchase agreement, 20, 30 years, amortize it, that cost, almost disappears for some of the incremental resiliency you add to a system.
So backup power and redundancy.
Backup power, redundancy, N+1 redundancy. Again, you have different sources, right? So it might be a waste source from somewhere else. It could be a boiler plant that's now extended its lifetime because you're not running it anymore. You just maintain it. It really depends. The answer is it depends, but anything's possible.
And it's how you started your conversation. What's old is new again.
Yeah, that's
So
right.
like backup power, like electric generation used to all be little power plants, and they centralized it and they realized, oh wait, we should decentralize again. So it's all coming full circle.
And then for the inline, for the 30 inch or larger, how do you work around, the routine maintenance of the sewer line?
So clearly the sewer line would be inspected prior to the installation. If we feel that the sewer line requires an upgrade at that time, maybe it needs to be lined, maybe it needs to be reconstructed, whatever it is, it's taken care of prior to installation. So like you mentioned earlier, you come out of the project with a better infrastructure than you had, going into the project. From a resiliency standpoint, I think the utilities do a very good job supplying power, right? Natural gas, electricity. We shouldn't discount the use of those facilities as part of a design effort, right?
Yeah, and I would say that coming out of New York, New York State passed the Utility Thermal Energy Networks and Jobs Act, mandating the utilities to figure out how to own, operate, and maintain these thermal networks. So I suspect there'll be some good data coming out, in the next couple of years for you to sink your teeth into regarding these larger, because it's inside the building versus outside the building. When you're talking muni, who's the authority having jurisdiction over that sewer line? One of the reasons why we love talking to college campuses is because they generally control their pipes.
Yeah.
They're in conjunction with the sewer authority because there's a lift station that then connects out to the outside world. But we can work with those pipes because they own them. And generally speaking, campuses already have a chilled water loop and a hot water loop that we can either augment, supplant. A lot of times they're like, wait, I'm paying for that for the next 30 years. You want me to get rid of that steam line? So there's some conversations or become more political in nature, but
Yeah.
it's a question of who's running the sewer.
And I think that the last comment, I mean, obviously this is important, but you have to make sure that when you're looking at other more traditional systems, there are risks with those as well, right? So how are those backed up? I know many hospitals don't have the luxury of being able to back up all of their chiller plants. They just don't have enough power. It's meant for life saving, right? So, there's a cost to that as well. So I had this question, I mean, when I was working at the hospital, the question is, well, what happens if, a big truck comes and runs into the Noventa power plant, the energy transfer station? Legitimate question, but what happens if it runs into the hospital's existing power plant? So, there's someone trying to, look at risks that were really no different than from traditional systems.
And in that sense, that's why I like the way you've all been basically answering the question of we're a yes and solution.
Yeah.
Not and because
That's right.
we've all seen on the ownership side is that we end up with a yes or no side. And we see that like communications. Radios are bad, cell phones are good. So you get rid of all the radios and go, oh my goodness. Sometimes cell phones go down.
Yeah.
So that's why I'm glad you said that. It's a yes and.
That's right. Nice way of putting it.
And then, yes.
Sorry, could I just jump in very quickly to build on Aaron's point about the Utility Thermal Energy Network and Jobs Act in New York? U10 or UTENJA is the way you'll hear that abbreviated sometimes. So if you see that in any press release, it's talking about the same sort of thing. So there are proposals that are going forward because of that. One of the 4 pilots that we filed for in New York State actually looks at working with a wastewater treatment plant. And it's for 2 of the reasons that you mentioned. First, reducing energy use in the buildings nearby, but then also looking at how it could have a positive benefit on the water that's actually then being released from it. As we know, a lot of places in the region are encountering algae blooms and things like that as there's warm water going out and as we're seeing shifting climate patterns. And there's, of course, organics still in some of the water as well. And so anything that we can do to help manage that is definitely seen as a positive. And I will just say that to your point around rules and regulations, the nice thing about a utility getting involved and having something to do with this is that we are already a regulated entity. So we're not trying to then create a new regulated entity or an entirely new set of regulations. The regulations for this will be new, and there's a rulemaking in New York that will be initiated as part of that legislation in the coming years. But we are already an entity that has a governing body that looks at how we do things and that would be able to then maintain and ensure that we are providing resiliency, redundancy, and safe, reliable service for our customers. So that might be a way to then integrate some of this. And as we start thinking about the scale up, helping to avoid some of those variations and to your point, making it so that the maintenance is manageable and that it might not be a single point of failure in the system if we have lots of different thermal resources that are coming into it together.
Do you see Massachusetts catching up to New York or following New York after it gets to a certain point in terms of regulations that you're talking about?
So it's an interesting question. I think, as I mentioned in my comments with the 2080 order that just came out, that's going to then sort of set the roadmap for how things will go forward in Massachusetts. The legislation in New York came about very quickly at the end of the last legislative session, and there was a significant involvement from the unions, again, as Aaron was mentioning earlier, in terms of the workers who are saying this is exciting. How do we be able to do more of this? And so I think my sense is there's a lot of very interested parties looking at this technology, but then also how it could be used for thermal energy network applications. And so my hope is that we continue to make progress, whether the legislation is there or not. So in Massachusetts, both Eversource and National Grid have pilot programs that were reviewed and approved by the DPU. So just working through regulation. New York happened to go forward on the legislative path because that was advanced in the session. And so I don't want it to say that we're sitting here waiting until legislation comes about. We certainly will be, an active participant in helping to shape legislation that we think could be of benefit to our customers, and we'll continue to work in the regulated pathways as well.
Great, thanks. Of course.
Any other questions? We actually get 13 minutes. I'd like to thank you all. Don't go anywhere.
Just give her the lookout.
Oh, yeah. That will work. Thank you, Paul.
All right, we have a few more questions from the virtual audience. One for Yurik and perhaps for Liz as well. Could the system be adapted for wastewater treatment plant tank walls, such as secondary clarifiers?
So, yeah, so we've looked at that. We feel that that's probably not the best application because there's a lot of functional equipment in those tanks, right? And you tend to get not the best flow over the heat exchangers. So we look for other places inside the treatment plant where the water is consistently moving. And we've been successful at locating those alternative locations.
Thank you. And another one about places to apply the technology for any of the three of you. Has your technology been implemented in retail stores, such as grocery stores?
The short answer is I would not necessarily in one, but that Leland Village up in Vancouver, there's a supermarket on the loop, and they obviously have a massive cooling load, so they are actually acting as a renewable energy source, if you will, by putting heat into that loop. So yes, we don't have it necessarily in a supermarket, but they're a great off taker and a great participant in as a center for a microgrid, if you will, a thermal energy network microgrid.
So for us, if the supermarket happened to be in a downtown area near a 30-inch pipe, it'd be a great off taker. They'd be a great resource because taking advantage of the sewer water to cool the condensing side of those.
And I would say also in New York City, we're looking at, there's a lot of apartment buildings that have like a D'Agostino's on the bottom floor, and those building owners hate it because it's destroying their building energy performance standards. So they've got a D in their lobby, not because of the apartment building, but because they're the supermarket on the ground floor. So when you can start again in those dense and urban environments and tackle two birds with one stone, use the supermarket's outflow to then feed domestic hot water to the people in the apartments above, it's a win-win.
Perfect niche. Yeah.
We're gonna keep going with some of the virtual, and then I'll switch over. Next question after.
Okay, so this question is for those technologies that use holding tanks. Are there typical tank sizes required for these systems? And are there rules of thumb based on the number of apartments or units on the system?
Since I use tanks, yeah. Multi-family residential, the easy rule of thumb is you estimate or quantify the total sanitary flow for the day, divide it by a third, and that generally gives you the right tank size. And the reason why is apartment building, there's a morning flow, diurnal peaks. People take showers in the morning, but it's really that evening peak. People come home, do dishes, boil pasta, run the laundry machine. We're trying to capture as much, if not all of that evening flow in that tank so that we can then make the hot water overnight. So that third of the apartment building size is really a good rule of thumb. But as far as these other buffer tanks, it all depends on what's your flow rate and what are your operational parameters, and then we'll base it on that.
Are you using it for peak or backup? Whatever, right? So.
Correct.
Could I follow up with that?
Please.
A quick question, just to tease that out a little bit. So there's a desire to do the 1-for-1 geothermal for wastewater energy recovery. I think that the 24/7 flow is probably going to be a large hindrance to that. So with respect to the holding tank, when you get into the details of that and let's say you're trying to design for that peak load, are there energy losses through that tank that you wouldn't otherwise see in the piping? And how much of an engineering design do you put into trying to meet that peak load 24/7 for critical infrastructure, maybe a hospital or something like that?
It's a case by case
yeah.
basis. Yeah. And again, the tanks are designed in such a way that they're not really leaching energy per se. Thankfully, we don't design the tanks. We've got really good market partners that are much smarter at tanks. And so we can, it's a case by case basis, really.
I mean, engineers hate when I say this, but it's easy. It's engineering.
Yeah.
You know the temperature of the storage. You know what it's going to. You know the heat loss. You oversize.
You oversize it, okay.
Yeah, but it
Yeah.
really, I mean, it's going to sound like a broken record. It really does depend what you're using it for, and that will help to take the size.
But is it safe to say that the 24/7 potential hindrance or lack thereof can be overcome with storage?
Yeah.
Across the board?
Yes,
Yes,
absolutely.
storage and proper siting.
Yeah.
Like you're trying to find that pipe, trying to find that flow point where you don't, it's less of an interest. So yes, there's.
But I mean,
Overcome.
also in large urban areas like, downtown Toronto, the low level, so the city of Toronto's done a great job of mapping this resource. I think the low level flows for some of the mid interceptors are 2,000 liters per second. That's the low, when you're looking at it, right? So there is 24/7.
I'm just doing gallons per minute.
Yeah, I know. So
It's a lot.
Yeah,
It's a lot.
it's a lot either way you look at it, but it is. So yeah, maybe on a specific building or smaller areas, but in large urban areas where you're going to have, a few wastewater treatment areas, you are going to have substantial 24/7 flow.
Yes, right, in urban areas, I agree.
And back to the earlier point, I mean, those sewers cannot go down because they handle a lot of material, right? So, there's, the municipality makes sure that they were not, I mean, things happen always, knock on wood, but those are generally running 24/7, 365 because they need to.
Just a follow-up question on that, maybe it's for Liz, from a utility perspective and, Liz, if someone was upstream of your system and they wanted to do this, would you require maybe some flow monitoring or you have flow meters at various levels? I know that just to try to get an idea of the flow levels and the dynamics that's going on, is that something that is insurmountable or is it not an issue or maybe an issue?
Yeah, so we do have flow meters throughout the collection system, and I've been racking my brain on, okay, where are there piping that's, over 30 inches or where, I'm thinking, just side note, like if we have a new development coming in and they submit an application to connect to the sewer, I might say, okay, great, and look at this, and pass along the information to try, because that's the best time to get right into it. And so, but yeah, I think on the flow side, we kind of have a sense of what the flows are around the system because we have multiple spots. Especially being a district, we have to know what's coming from each town. So we have probably more than other facilities may have. So
that's perfect. Thank you. Thank you, Liz. And we're gonna jump to a live audience question here. If anyone has any additional questions. Yes.
So I have another question for Liz and your team. Your sounds like their technology is more specific to the heat exchanger, so Liz, were you working with another third-party consultant to design or come up with an overall system, or does Yuri kind of do all that?
Yeah, Yurik is doing all of that. So we've done that conceptual design and now they're taking that to the next step of that process. Frank, you can speak more on that. but-
Yeah, so that's what I've done. I've built an entire team that will carry out the turnkey project, if you will.
Which is great. As a utility, I can't design that. I don't have the resources to do that. So it's been excellent to have, Yurik come in. I know you guys do too. So, having the technology providers come in and do all of that engineering, the whole kind of package. Good.
Yeah, lucky for you guys, our stuff is still novel in North America. So we understand it's highly engineered, so we have to do a bunch of complementary work just to make sure our stuff is deployed properly, because the last thing any of us need is one of these systems be put into the market and have it fail, because then that's just bad for everybody.
Thank you. We'll take one more question in the audience and then maybe virtual. I think we're getting close, and I know it's been a long one. We try to get 12 o'clock and then we'll be back here at 1. But any in person and additional question, and then I'll go to Amy. Okay, Amy? Nothing? Okay, perfect.
Could I ask-
We're gonna get back.
Could I ask one question?
Yes, sir.
We talk about the thermal storage. I'm trying to understand the storage. Are we storing warmed water or cooled water? Or are we just storing water that's at the temperature of the sewage system?
For our system, we're just storing the wastewater. So
Just storing
if
wastewater.
it's
not
coming out of
thermal
a building, it's 70 degrees. If it's at a brewery, it might be 100 degrees, or
Right.
commercial laundry. Yeah.
You're just storing at temperature, not raising or lowering.
Well, correct. But again, for our Piranha system, after we run through our system, we then have to send that hot water, and we generally put it into like a hot water or a preheat,
Right, well, but it's already, that's a condition, yeah. It's not.
correct. Yeah.
right.
But we're just capturing sanitary and holding it there so we can use it.
Yeah, okay, thank you.
Typically, it's very tempered water after the heat pump, right? So cold, warm, or both sometimes. You can have dual tanks depending, many situations you need both simultaneous heating and cooling. So again, it depends. It's the weasel answer, but it's the answer that keeps coming back. But for us, it's typically the already conditioned water that's put in storage.
Yeah, because I'm just trying to, because you can't, if you were running the compressors twice, once to bring it up to a temperature to store it, and then you drew that down with another compressor to bring it to the actual load, then you'd really bring your CLP down, because
That's right.
you'd have to do it twice. So
Correct.
but you're not talking about.
No.
No, didn't make sense, but
Yeah.
I'm just trying to picture
Good
this
job.
all in my head. So,
Perfect.
Yeah.
And any other questions? And Mike, you've been giving, I looked at you, I thought you had a burning question.
Oh, no, I just wanted to add before we closed out that I think it's Liz, it's great having you here. What I've seen moving forward with this is the wastewater industry is typically very conservative. The consultants that serve the wastewater industry are typically very conservative. I think the presentation here today has done an excellent job of highlighting the technical benefits of this. I think the challenges going forward are really going to be getting that entire community on board.
Yes.
This is the beginning.
And this is the beginning. Yes.
Yeah, and so just some specifics about lunch is there's bag lunches that folks can go to that room, and then they can come back here. And just as you go through the main atrium area, just so be mindful of discussion and so forth. And then you can go outside on this beautiful veranda outside, but just don't stray away from the concrete.
We're an orange vest.
So, with that, we'll thank you very much. First of all, thank you very much to the panelists, both here and for